Okay, folks. So in the last video, I sort of kind of introduced the idea to a t-test, and I stopped at this slide on the t-test summary. So I'm going to start here and then do two examples for us. Okay. So as you can see here, we have a comparison between a single sample t-statistic and what we're doing within this unit. No, where'd it go? Within this unit, the independent samples or the independent measures t-test. Again, just to reiterate, before we found sample variance, used that to find estimated standard error, and that was our denominator when we did m minus mu over estimated standard error. Now we have two samples and two of everything. Going wild. So this time, instead of finding sample variance, there's a little p symbol there because we're finding pooled variance. Sum of squares plus sum of squares over the DFs. Again, two of everything. We use pooled variance to find estimated standard error. And then in our t-statistic, we do m1 minus m2 over estimated standard error. Okay, so let's put that together in steps. Same basic steps that we've been doing. What's the null? What's the alternative? The null says that there's no difference between population means. The alternative could say, hey, there is a difference. Let's test for it. In this case, a two-tailed test. Okay. To find the DF, I like to do what I think is the easiest way. Add them together, subtract 2. Okay. You have to know if your alpha is one or two-tailed, and then you go to your T table, and you find your T critical. Okay. Just to lay this out further, we find pooled variance, sum of squares plus sum of squares over df plus df. Use that to find estimated standard error using pooled variance all under the square root. And then compute the t. Again, ignore excuse me, ignore this part. m1 minus m2 over estimated standard error. Then you make a decision, right? Do we reject or fail to reject? Is it beyond the t critical, positive or negative? If it is, we reject. If it isn't, we don't reject. Okay? So let's do a full example. Okay? Let's say we have two samples, two very small classes because I have to come up with this actual data. Professor A, 6 students. The mean on their final grades in GPS 110 is an 83.33. Sum of squares, 475.33. Professor B, 8 students. Their mean is a little bit higher, 84.25. Sum of squares of 361.5. You can sort of eyeball this. There's 6 people, there's 8 people. Is this going to be different? Maybe not, probably not, but let's test it. Okay, so you have everything we need there, and I'm going to walk us through the steps. Right. Again, alpha's 0.05, we got means, we got sum of squares, we have n, we're good to go. Okay, null, no difference. Alternative, there is a difference. These null and alternatives won't be very specific within these examples. We're comparing it to 0. So this one is pretty much always going to be 0. The only thing that's going to change here is the sign. It's still going to be compared to 0. Okay? We figure out what our T critical is. We've already shown that it's 2.179. Again, 6 plus 8 is 14, minus 2 is 12. It's our DF, and it's two-tailed. We keep going. I'm going to walk it out with another example so you can see the full math, but here's what it looks like here. Pooled variance, sum of squares plus sum of squares over DF plus DF gives us 69.7. We use that all under the square root. You can see the formula in the top right if you've forgotten. We take pooled variance over 6 plus pooled variance over 8, all under the square root. So that's that 69.7 divided by 6 plus 69.7 divided by 8. Do those fractions work that math? Then add them together, then take the square root. We get 4.51. Sample means 83.33 minus 84.25. And then here's that 0 part I was telling you about with the U1 minus U2. But that's what we assume from the null is always 0. So I have that here. I'm not going to put that 0. That 0 doesn't matter. It's always going to be 0. 83.33 minus 84.25. over 4.51. T of negative 0.2. We compare that to our T critical of plus or minus 2.179. Is it significant? Nope. All right, so we failed to reject. There's not a significant difference in grades between the two professors. T, parentheses 12 was our DF, same as before, equals negative 0.2. P is greater than 0.05 because we failed to reject. Okay, so you have that example worked out there. I also came up with another one. Okay, and this one I've worked out on the right side over here. So we have two samples. We are comparing, is the MPG of a Honda Accord different than the MPG of a Toyota Camry? Okay, I was kind of lazy and used the same sample size, pardon me. I have taken 6 Honda Accords. Their mean is just shy of 30 miles per gallon. The sum of squares of just shy of 37. I have 8 Camrys. Means a little bit higher, 33 miles per gallon. Sum of squares is 42. Okay, so we have everything we need. Alpha's 0.05. Is there a difference? Let's do some math. Come over here to the right. U1 minus U2 is 0. Always going to be that. Alternative, U1 minus U2 is not equal to 0. Difference. That determines that symbol there. T critical, pardon my scribble, but I was doing 6 plus 8 minus 2 gives us a DF of 12. It's two-tailed. Alpha's 0.05. T critical is plus or minus 2.179. Again, I just copied the same information over. We start with, let's find pooled variance. Sum of squares 1 plus sum of squares 2 over df1 plus df2. 36.8 plus 42 over 5 plus 7 is 12. That gives us pooled variance of 6.6. We take pooled variance. What are we finding? Do you think to yourself, well, obviously we're finding estimated standard error. You're correct. All under the square root, 6.6 over 6. 6? Yeah. N? Yes, N. N goes here, same as before. DF goes here, N goes here. 6.6 over 6 plus 6.6 over 8. Add those to, work out the fraction. Add those together, 1.1 plus 0.825. All under the square root and gives us 1.39. We take that, we throw it under our t-test. 29.83 is M1. Doesn't matter that it's negative. Let's keep direction. Let's keep M1 M1. 29.83 minus 33 over 1.39 gives us negative 2.28. I just made up these numbers randomly, but my goodness, is that close to the T critical. T critical is plus or minus 2.179. Kind of sketch that out here. 2.179 on both sides. Negative 2.28. Whew. We are close, but we are in that shaded area. My goodness, that's fantastic. So we're going to reject the null. There's a significant difference in the MPG of the Accord versus the Camry. T, parentheses 12 is the DF equals negative 2.28, comma, P is less than 0.05. And if you're thinking, could I do the effect size? I could, but we're not going to do that here. Okay. That's taking us through 2 examples. Similar steps. We just have 2 of everything. Let me know if you have questions.